Welcome back. This is an Aleks homework video on using the small x approximation to solve equilibrium problems. I call this fudging, and it is awesome because you can do what looks like an absolutely terrible problem in just a couple of minutes. What we're going to see here is that the pressure constant expression here, the pressure constant, is very, very dinky small. In this example, we've got 2.10 to the negative 6, all right? That's 2 millionth on the other side of the decimal point, so tiny, tiny, tiny. That means that you are going to have the tiniest bit of product made. So because of that, you can really just kind of fake it, and I'll show you what I mean. Normally, you're going to take the expression, the case of P expression, which is the pressure of your products. In this case, it's squared since it's the coefficient is 2, divided by the pressures of your reactants taken to the power of its coefficient as well. So the NO would be squared here, the Cl2 would be to the first power. And they give you the case of P, so I just set that equal to each other. Then normally you want to put this in equilibrium. So they told you what it was initially, that you had nitrogen monoxide at 14 atmospheres, the chlorine gas at 12 atmospheres. Of course, you didn't have any of your product yet. What are you going to do? The ice table, this is always the tricky part of the ice table. What do you make X? Normally, whatever I'm trying to find, if I can, I'll make that X so that I have one less step at the end. A lot of people do that. I think you could probably go from different routes here, but if you're asked to find the equilibrium pressure of the NOCl, which is your product, I just make that plus X and then go back to the balanced equation and see that the NOCl has a coefficient of 2. Well, the NO will have a coefficient of 2. So if your NOCl is your plus X, then your NO is going to be minus X. But Cl is only to the 1 mole of Cl2, so it is only going to lose a half of an X as the product is being made. So there's your tricky space. So then you're at equilibrium. You've got the pressure of the NO is 14 minus X. The pressure of the Cl2 is 12 minus half X, that should be 0.5 X. And then your PNOCl is X. Okay. So the next step always is to put it back into the expression. So case of P equals, in this case, X squared over 14 minus X squared times 12 minus half X to the first power equals 2 times 10 to the negative 6. Well, that is awfully hard. I did this problem. It took 25 minutes to do it. There's so many steps to it. You're so unsure that your algebra is right. I don't know very many people are so confident of their algebra that they can do an entire sheet and just know that it was right. I had to check and check and check and check. So this is just like the basics of the expression. So you're going to have blah, 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 blah equals 0, and then I look and see that I've got x to the cube, and I can't even do a quadratic on that. So this is just, I'm not going to say it's undoable. Smarter people than me could maybe do it. I can't do this. So that means either you can't do it at all, or you fudge it. And so I'm going to fudge it instead. So do you see? I wouldn't even write, if I were taking notes on this video, I wouldn't even write that down because I'm not going to use it. I'm essentially going to look and see that 2 times 10 to the negative 6 is so small that my product, my X is my pressure of my product, is going to be so tiny that I'm just going to ignore it. I'm going to pretend it's not there, which means that I don't have to do all of this FOIL and multiplying squares and cubes and all of that. All I'm going to do is simply going to make it go to 0 I'm going to approximate it down to 0 and then rewrite the expression. So here I've got the expression as 14 squared times 12 on the bottom, and that's easy. That's no problem. And so you simply take the square root of that, and I get the square root as 0.06858 whatever. And then if you realize that x is the pressure of your product, and I made x to be that so that I would have it done, they just asked for one significant digit, which is 0.07 atmospheres. So to answer the question, you're kind of lying here. Can you predict the equilibrium pressure of NaOCl only using the tools within Aleks? Yeah, if you fudge it, because there is nothing in Aleks that'll tell you how to do something to the x cubed power, ugly. So I'm just going to say yes, and then if you said yes, what is that pressure to one significant digit was 0.07, and then they give you the units of atmospheres. So I hope this makes you happy that you can actually get an answer without doing ugly math. Hope you're doing well.